properties of the definite intervals. So if we change the interval from A to B, when we consider the A always first on the left hand side and then the B on the right hand side. So this is what we assume, that A is less than B. If we change this from B to A, then what all we need to do is just put the minus in the front. The property follow that is that if we're talking about the integral, which is the area under the curve of the function f of x, when the integral from a to a, which is just the same point, and the area have to be 0. We have the 4 properties of the integral. The first one is easy to see. Let's say we have a constant function, and assume that we have a constant function like this. Then we have the interval from a to b. So a to b will be the width. So b minus a is the width. And the height will be c. So it will equal to the height times the width. Property number 2, we can apply the theorem number 4 to do that. So from the sum of the function f of x and dx, we will get it will equal, so on the left hand side, it will equal to the limit of the Riemann sum f of xi plus g of xi times delta x. And because of the sum, we can distribute the delta x, so that will be the limit when n approaches to infinity of the sum of delta x f of xi plus delta x g of xi. And we can separate them because this is the sum. So we can separate delta x f of xi plus the limit of delta x g of xi. Then this one, the first one, give us the integral of the function f of x dx from a to b, and the second one give us the integral from a to b of the function g of x dx. Similarly, in property number 4, we can understand this is like f of x plus negative of g of x, and we apply the same way as we prove it in property number 2. The proving in property number 3 is easy to see that c is just a constant, so you pull out a c, then you can use the same idea of like this. So we have c and this part, right? So you can pull out a c, and that will give us the integral of c times the integral of f of x dx from a to b. Example number 6, we want to use the properties above to evaluate the integral. So first of all, we can separate them. So using the property number 2 that we just proved, so it's equal to the integral of 4 plus the integral of 3x squared dx. So 4 is a constant, so 4 times 1 minus 0, we use the property number 1. And we can pull out the 3, so we use the property number 2. So we got 4 right here, copied out the 3. We learned in 4.1 before, the integral of x squared from 0 to 1 is 1/3. So the answer would be 5.